Imagine a place so dry that some weather stations have gone decades without a single measurable drop of rain. Then imagine another desert that shivers under snow and freezes for months. Same label, totally different causes. Stay with me. By the end, you'll see deserts not as mistakes, but as the byproducts of how our planet moves air, water, and cold. There are a few big ideas that explain most deserts: air circulation, mountains, cold oceans, and distance from the sea. Learn those and you can predict where deserts will be and why they can change. Start at the equator where the sun is strongest. Warm air rises, carrying moisture from tropical rains high into the atmosphere. That air cools and drifts poleward, then, about 30 degrees north and south, it sinks back down. Sinking air warms and dries. That persistent downdraft creates broad belts of clear skies and little rain. This is where the great hot deserts form. Think of the giant sand sea across northern Africa, Sahara Desert. It's not just hot sand. It sits under that sinking air, day after day, year after year. That same physics is why huge deserts line both sides of the tropics across the globe. But the Hadley cell is only part of the story. Mountains can steal moisture before it reaches inland. Moist air moving from an ocean climbs to cross a mountain range, cools and dumps rain on the windward side. When the air falls on the leeward side, it is dry and warm, and a rain shadow forms. Imagine winds pushing clouds up over a tall range like the Himalayas. On the far side, the landscape can be a desert because the mountains took every drop. That mechanism helps explain continental deserts far from coasts. Now meet the rule-breaker deserts. Some coasts should be wet because they face the ocean, but instead they are bone dry. The secret is cold ocean currents. Cold water cools the air above it so that it cannot hold much moisture. That air blows onto the coast and produces fog, not rain. A dramatic example is the coastal stretch next to the Atacama Desert, one of the driest places on the planet. The cold current offshore helps create almost no rainfall for centuries. Coastal deserts like this are weird cousins of the big subtropical ones. So far, rising at the equator, sinking at 30 degrees, mountains stealing rain, cold currents stealing moisture. But deserts still surprise. There is one more big actor: distance. The further you get from the ocean, the harder it is for moist air to reach you. Central Asia, for example, sits so far inland that ocean storms lose their water long before they arrive. Combine that with rain shadows and you get dry plains and gravel deserts. Then there are polar deserts, places that are technically deserts because they get so little precipitation that ice, not liquid rain, dominates. Frigid air holds almost no moisture. Big, cold, and dry, very different from sandy deserts, but desert nonetheless. Deserts are not forever. Climate shifts change where air rises and sinks, ocean currents shift and mountains erode, and humans can accelerate desertification by removing vegetation and drying soils. Some areas that were once green are becoming more desert-like, not because of a magic rule, but because we change local water and vegetation cycles. At the same time, deserts host life specially tuned to dryness. Plants that live on whispers of moisture, animals that time their life cycles to rare rains. These adaptations are part of the desert's logic. Picture a single scrub that blooms for 1 week after a rare thunderstorm, covering the ground in color, then disappears. The desert waits, not dead, but dormant. That patience is a consequence of scarcity, the central theme of every desert's existence. Understanding why deserts exist is not trivia. It helps us predict where water will be scarce. It helps us predict where agriculture will struggle. It helps us see which regions are most sensitive to climate shifts. It explains why some deserts are expanding and why others might see rare new rains. Deserts are places where Earth's air, water, and land interact to keep moisture away. Whether it is the global scale of rising and sinking air, or the local theft of rain by mountains, or cooling theft by ocean currents, or sheer distance from life-giving seas. Deserts are nature's outcome of distribution, not accident. Next time you see a sand dune or an icy plain, don't think nothing here. Think of a planet sorting its moisture day after day into patterns that created those extremes. Deserts exist because Earth moves air and water like clockwork, and sometimes that clockwork stops the rain from ever arriving.